The lights, the water, the fuel. Invisible control systems make them work, and attackers want in. Every day, machines obey instructions you never see. Industrial control systems run pumps, breakers, and valves. SCADA systems supervise far-flung sites from control rooms. These networks were built for reliability, not internet threats. Many devices still run decades-old software and trust every neighbor. That mismatch is why attackers prize them. In the next minute, we'll open the black box and show practical defenses you can use, starting now. Think of ICS as a factory's nervous system. PLCs handle low-level motor and valve signals. RTUs send telemetry from remote pump stations. HMIs are operator screens showing sensor values and alarms. Historians store time series process data for analysis. Engineering workstations program logic that runs the plant. Each component matters because attackers aim to change those exact values. Keep these pieces in mind. They become targets, and tomorrow we name the weakest links. SCADA, DCS, and ICS sound interchangeable, but they differ in scope. SCADA supervises dispersed sites like substations and pipelines. DCS tightly controls plant floor processes inside refineries or chemical plants. ICS is the umbrella term covering both. Operational technology, or OT, is the network and procedures that make control systems work. If you come from IT, picture SCADA as remote traffic control and DCS as the local engine room. Next, we'll explain why most of these systems feel old. Many industrial systems arrived long before the cloud. Equipment life cycles stretch 15 to 25 years. Vendors ship specialized software that only runs on older Windows releases. Protocols like Modbus and DNP3 prioritized uptime over authentication. Facilities value availability above all. Patching risks costly downtime. Flat networks and shared credentials persist. The result, legacy tech meets modern connectivity, and that collision creates an attack surface that invites opportunistic intruders. Up next, real incidents that prove the danger. Stuxnet rewrote expectations by altering PLC logic while hiding normal readings from operators. Ukraine's grid attacks used phishing to move from corporate email into breaker controls. Triton targeted safety systems, risking human lives. Oldsmar's water incident showed an attacker could change chemical dosing via remote access. Colonial Pipeline proved ransomware in IT can force OT shutdowns. These stories share a pattern. Basic failures, phishing, weak remote access, and flat networks lead to catastrophic physical effects. Now, let's look at how attackers actually move. Attackers often begin where defenders relax: email inboxes and remote support tools. A successful phish yields credentials. From there, they pivot into OT using jump hosts or shared vendor access. Misconfigured VPNs, exposed RDP, and default PLC passwords make lateral movement easy. USB drives and compromised integrator laptops slip malware past perimeter checks. Sometimes attackers learn PLC commands on the fly. The playbook is brutally simple, and next we'll map that playbook to defensive steps. Before you buy tools, build a map. An accurate asset inventory lists PLCs, RTUs, HMIs, historians, engineering workstations, and network gear. Note firmware, OS, location, and function. Use passive discovery in OT to avoid process disruption. An inventory exposes single points of failure and prioritizes protection. Without it, you defend by guesswork. Once you can see your devices, you can segment and harden them effectively. And we'll show that segmentation next. Segmentation turns a flat plant network into a series of islands. Use zones and conduits to separate business IT from OT. Inside OT, isolate critical control loops from non-critical systems. Firewalls should deny by default and allow only specific protocols. For the most critical loops, consider one-way data diodes. Proper segmentation confines a breach to a small area and prevents catastrophic lateral spread. Next, we'll cover device hardening that reduces the number of exploitable entry points. Hardening focuses on simple, high-impact changes. Remove default PLC and HMI passwords. Disable unused services and close unnecessary ports. Enforce multi-factor authentication for all remote access. Lock engineering workstations. No email, no browsing, ad hoc USB use. Apply application allow listing instead of relying solely on signatures. Treat engineering PCs like master keys. If attackers control them, they control logic. After hardening, we'll tackle secure remote access that balances safety with vendor needs. Remote maintenance can be the riskiest portal. Require MFA and modern VPNs or zero-trust access. Use time-bound vendor sessions and recorded jump hosts as choke points. Never expose RDP, VNC, or HMI ports to the public internet. Approve and monitor vendor tools and restrict privileges to the minimum needed. These practices cut common attack paths without halting maintenance operations. Coming up, monitoring that gives you seconds to decide when an incident starts. Patch management in OT needs judgment, not fear. Prioritize patches by criticality and process risk, not only CVSS scores. Test fixes in a lab or during planned outages. When patching risks uptime, compensate with segmentation and access controls. Maintain an inventory of firmware and OS versions to identify devices that cannot be patched. The goal is risk reduction, not reckless patching. Up next, backups, golden images, and drills that shorten recovery time. Backups save lives in cyber incidents. Keep offline tested backups of HMIs, historians, engineering workstations, and PLC logic. Version control PLC programs and secure checksums to detect tampering. Maintain golden images for quick rebuilds. Regularly run restoration exercises to validate recovery time objectives. Practice restores under pressure so teams learn their roles. These habits convert a ransomware drama into a manageable outage. Next, we'll prepare incident response tailored to OT realities. OT incident response needs plant-specific playbooks. Define roles, isolation steps, and safe shutdown procedures that avoid harming people or equipment. Run joint tabletop exercises with IT, OT, safety teams, and leadership. Pre-establish vendor contacts and escalation paths. Practice switching to manual modes so operators can run essential processes if HMIs fail. An OT-aware IR plan shortens recovery and reduces physical risk. Coming after this, governance and procurement changes that prevent problems at the source. Governance and procurement lock security into long life cycles, require signed firmware, SBOMs, and hardening guides from vendors. Define patch SLAs and supply chain visibility in contracts. Track KPIs like % of assets inventoried, MFA coverage, and mean time to detect in OT. Use standards such as NIST SP 882 and ISA IEC 62443 as governance scaffolds. Buying with security in mind reduces future surprises and makes audits predictable. Up next, why people and culture matter more than any single control. Technology fails without human practices. Train engineers on phishing risks, USB hygiene, and secure change control. Train IT on industrial constraints and safety priorities. Reward staff for reporting anomalies rather than punishing mistakes. Practice cross-disciplinary drills to build trust between IT and OT teams. Security succeeds where curiosity and safety culture coexist. These changes are low cost but high impact. After this, we'll pause for a quick recap before diving into quick quarterly wins. Mid-video recap: industrial systems control physical processes, not just data. Legacy devices, exposed remote access, and flat networks create risk. The defensive path includes inventory, segmentation, hardening, monitoring, and recovery exercises. People and procurement close many gaps. That summary gives perspective. But the fastest wins are concrete actions you can start this quarter. Next, we'll list the short actions that yield the biggest immediate risk reduction. Quick wins: enforce MFA for all remote OT access, inventory assets with passive tools, and remove any exposed RDP or HMI ports. Backup PLC logic and store copies offline. Rotate default credentials and lock engineering workstations. Stand up a jump host with session recording for vendor sessions. These steps reduce risk dramatically without big capital outlays. Implement them now, and you'll harden common attack paths before attackers notice. Then we'll scan forward to emerging trends you should track. Look forward. Vendors are shipping PLCs with signed firmware and encrypted links. Zero trust ideas are moving into OT with careful timing. SBOMs improve supply chain visibility and vulnerability triage. AI tools help baseline normal ICS traffic and flag deviations. Complementing rules, 5G and edge computing extend the attack surface and demand tighter segmentation. Regulation is rising across energy, water, and pipelines. These trends change how you plan long-term defense. And next, we'll wrap with a practical checklist. Practical checklist: maintain an accurate asset map, segment OT networks, rotate credentials, enforce MFA, monitor passively, patch smartly, and test restores regularly. Train teams and include OT in incident response plans. Buy devices with signed firmware and require SBOMs. Track simple KPIs to show progress. Prioritize actions that reduce blast radius immediately. Take ownership of one of these items this week and report back on progress. In the final section, we'll summarize the promise of doing this work. Securing ICS and SCADA is not a single project. It's iterative work built on visibility, segmentation, and people. Small, deliberate changes produce outsized results. Attackers rely on neglect and convenience. Your defenses rely on discipline and visibility. Start with the inventory and the MFA rollout. Over time, build monitoring, patch programs, and recovery routines. The systems you protect keep cities lit and water flowing, and your efforts will keep them resilient. If this helped, hit like and subscribe for more practical ICS security guides, and tell us in the comments which quick win you'll start this week.